Lesson 223, identifying rates of change. So I'm going to stop here real quick on the vocab and kind of draw your attention here to this f of b minus f of a divided by b minus a. To keep it easy, I think it's easier if we use the formula y2, if it's just noted, y2 minus y1 divided by x2 minus x1. Okay, essentially, it's the same exact thing. It's just stated different. We're given coordinates, and it's easier if we use y2 minus y1 divided by x2 minus x1. And you'll see later in a bit that labeling and how it's a lot simpler to use, a lot less confusion. So now going on prereq skills real quick. This here, that's a positive slope. This here, that's our negative slope. This one here, there's no rise, but there is a run. So this is a zero slope. And this here, there's only rise. There's a rise, but there's no run. So this slope is undefined. Or no slope. But you'll get into that later in math later on, further on. You guys move on to math 3. Okay, so now example 1. So the standard was calculating the rate of change only given the function. So we are given a function here. And it's asking us to calculate the average rate of change for the function between x equals 1 and x equals 3. So first thing we got to do, we have x values. We got to find y values. So I'm going to start with finding the y value for the 1 first, which means we got to plug that 1 back in. So we have 1 squared plus 6x, oops, not 6x, 6 times 1, plus 9. Okay, and we got to simplify that out. We have 1 squared is 1, plus 6 times 1 is 6, plus 9. That gives us 16. So when we plugged in 1, we got 16, and I'm going to write that quite big. Now looking at the next one, x equals 3. Now we got to plug 3 in. So now if I plug 3 in, we have 3 squared, can't forget my parentheses, plus 6 times 3, plus 9. Okay, so now simplifying that out, 3 squared is 9, plus 18, plus 9. That's, let's see, that's 18 plus 18, that's 36. So I plugged in 3, and I got 36. Okay, so now I have my 2 points, and now I can find the rate of change between these. So remember that formula that I threw out at you. We have y2 minus y1 divided by x2 minus x1. Okay, and we got to label these. Remember that these are coordinates, so this is x1, y1. I'll label this one x2, y2. Now, it doesn't matter which one you label what, as long as x1 and y1 stay together and x2 and y2 stay together. We could have easily made these x2, y2, these x1, y1, but I chose to do it my way. So now we're going to go ahead and we're going to plug in the information that we have. So y2 is 36. 36, the minus sign from the formula. y1 is 16. So 36 minus 16 over x2 is 3 minus x1, which is 1. And simplifying that out, 36 minus 16 is 20. 3 minus 1 is 2. Simplify one more time, 20 divided by 2 is 10. So now the rate of change between those two is 10. And that'll be our final answer there. You can box it in red, whatever color you want. Now going on to example 2. So example 2, this time we're not given a function and we're given a graph. Right, so we're only given the graph of the function, but we still have enough information to go ahead and find our rates of change. And I think this one's quite a bit easier. So we've calculated the average rate of change for the function between the following values. So x equals negative 4. So at negative 4, right, we know x equals negative 4 right here. So we just have to find the coordinate of where this graph is at negative 4. So if we're looking at it, it is right there. Right? And I'm going to remove that, and we're looking at right there. So this coordinate at -4, it's at, what is this, 5. And now at -3, I'm looking at -3 here. It looks like it's at the origin. So at -3, our graph is at 0. Okay, and now we can do our rate of change formula to find the rate of change between these two, right? You just got to label them, x1, y1, and we have our x2, y2. And we know our formula. I'm just going to write it once right here, y2 minus y1 divided by x2 minus x1, because it's going to stay the same for all of these. Okay, so my y2 is 0. The minus sign from the formula. Y1 is 5. Right, and I'm just pulling it out of here. Divided by x2 is -3. The minus sign from the formula. And x1 is -4, so we have a double negative here. Oops, -4. And now we simplify. 0 minus 5 is -5. -3, this turns into a plus. Plus 4 is a 1. So our average rate of change here is -5. Right, and we look at that. 1, 2, 3, 4, down 5 over 1. That's correct. Okay, now we go on to the next two. So when x equals -3, we already know that at -3 it equals 0, right? Or you can go ahead and refer to your graph again. At -3, it's right there. The graph is at 0. So -3 comes 0. And now at -2, our graph is at, going down, looks like it's at -3. So at -2, we're looking at -3 right there. So -2, -3. Then we do our same thing. You just gotta label these x1, y1, x2, y2, and we do our math. And I'm gonna do this one in blue this time, just so we can see the difference, because that was that first one there. So again, start with y2. That's -3. The minus sign from the formula. Y1 is 0. Right, so this is kind of getting redundant. X2 is -2. Minus sign from the formula. X1 is -3, and we got another double negative there. Right, -2 minus -3. Simplify this out. -3 minus 0 is -3. This turns into a plus sign. Right, we have two negatives next to each other, turned into a plus sign. That is -2 plus 3, which is 1. And our average rate of change here is -3. So if we're looking at from here to here, down 1, down 2, down 3, over 1. So down 3 over 1, -3 over 1. That's our slope. It's our slope and our rate of change. Okay, and now our last one here, just for the sake of redundancy, I'm going to do this one pretty fast. So we have -2, -3. At -1, our graph is at, let's see, -1, it's at -4. Let me double check that. -1, -4, yep. And then we have our x1, y1, x2, y2, x1, y1, x2, y2. I'll do this in purple. I'm going to do it up here. So that's -4 minus -3. Right, y2 minus y1. Divided by x2, which is -1. The minus sign from the formula. X2 is -1. Nope, x2 is -2. Almost messed up. So -1 minus -2. So then we can change these to plus signs, because we know that double negatives are positive, and we can simplify. -4 plus 3 is -1. -1 plus 2 is 1. Our slope there is -1. And if we look at it from -2 to -1, down 1 over 1, that's correct. Okay, so this was how to read it off a graph. So remember, you're just finding those coordinates. Whatever x value asks you to find, just go find its y and then do your y2 minus y1 divided by x2 minus x1. Okay, example 3. We calculate the rate of change only given functions and comparing results to another function. So for this function, f of x equals x minus 3 squared minus 2. So it's asking, is the rate of change greater between x equals negative 1 and 0 or between 1 and 2? So I'm going to rewrite this up here. So if it x equals negative 1 and x equals 0, or is it greater between x equals 1 and x equals 2? So which one has the greater rate of change? So first thing you got to do, right, so I'm going to work on negative 1 and x equals negative 1 and x equals 0 first. So we got to plug those in and we got to find the y values. So first thing I'm going to do is I'm going to plug in negative 1. So I'll have negative 1 minus 3 squared minus 2. So negative 1 minus 3, that gives me negative 4 squared minus 2. Negative 4 squared is 16 minus 2, that's 14. So for my first point here, if I plug in negative 1, I get 14. Now I got to plug in my 0. And I'm going to do that underneath. So if I plug in my 0, I get 0 minus 3 squared minus 2. So this is negative 3 squared minus 2. Negative 3 squared is 9 minus 2, that's 7. So for 0, when I plugged in 0, I get out a 7. So now I got my two coordinates. I got my x1, y1, and now my x2, y2. And I can do my formula. Right, I'll go ahead and I'll write the formula again for you guys, just because I want you guys to have as much exposure as possible so you never forget this. y2 minus y1, x2 minus x1. And now we can plug these in. So my y2 is 7, and I'm going to try to fit it in right here. So that's 7 minus my y1 is 14 divided by x2 is 0 minus my x1 is negative 1. So that's negative 7 divided by positive 1. And that gives me a rate of change of negative 7 for x equals negative 1 and x equals 0, right? So we compare. Now we got to compare it to x equals 1 and x equals 2. So I can draw. Hopefully I have enough room here. I'm going to write this one a lot smaller. Okay, so first I'm going to do my rate of change for x equals 1. Okay, because we want to compare this set to this set. Okay, we're going to determine which one has the greater rate of change. So, again, plug these in and get your y. So we have 1 minus 3 squared minus 2. 1 minus 3 is negative 2 squared minus 2. That's 4 minus 2, that's 2. So when we plugged in 1, we get 2. Now I'm going to plug in my 2. And it's all going to the same quadratic there. 2 minus 3 squared minus 2. That's a 2. That's negative 1 squared minus 2. That's 1 minus 2. Negative 1. So when we plugged in 2, we get negative 1. Okay, and I'm going through these quick because you guys should know how to do these by now. We've had quite a few examples already. So now, again, label your x1, y1, x2, y2, and we do our equation. So we have negative 1 minus 2 divided by x2, which is 2, minus 1. So now we have negative 1 minus 2, that's negative 3. 2 minus 1 is 1, that's negative 3. Okay, so now we figure out which one of these has the greater rate of change. Okay, and this part is a bit tricky. So the greater rate of change, so this one here, if we're looking at, so between x equals negative 1 and x equals 0. So if we're looking at this one here, and let's say we're looking at a number line. So here's my number line. Here is 0, -1, -2, -3, -4, -5, -6, -7. So from 0 to -7, right, let's say there, if we're looking at this, the rate of change, so the amount we changed was 1, 2, 3, 4, 5, 6, 7. Right, we changed a 7 total of spaces on this one. So the rate of change there was a total of 7. Now if we're looking at a number line here for -3, let's say this is our 0, this is -1, -2, -3. Now if we're looking at the rate of change from 0 to -3, we have a total of 1, 2, 3 spaces of change. Okay, so this is where it gets tricky because people assume that because -7 is a smaller number, it's a smaller rate of change, but it's actually the greater rate of change, right? Because again, from 0 to -7 is the total of 7 spaces. From 0 to -3 is a total of 3 spaces. So the change from 0 to -7 is larger than the change from 0 to -3. Okay, so keep that in mind because that's the part that tricks a lot of students. Okay, and then our final example here, we got calculating the rate of change given a table of values. So we need to find the average rate of change between x equals -0.75 and x equals -0.25 for the following function. So this here is the function that's given to us. So we know our first x is going to be this here. So if that's x1, this 3.44 is going to be my y1. Then it tells us x equals -0.25. That's going to be my x2. And then this is going to be my y2. And again, remember that formula we have y2 minus y1 divided by x2 minus x1. And we go ahead and we plug them in. Right, so this one, all the data is given to us already. So we got 8.44 minus 3.44 divided by my x2 is -0.25 minus a -0.75. And we just got to simplify this out. 8.44 minus 3.44, that gives us 5 over -0.25, that turns into a plus 0.75, gives us 0.5, and then 0.5 divided by, 5 divided by 0.5 gives us 10. And that is our rate of change there. Okay, so few different ways that we can get our data from quadratics. So we had chart, we had graph, we had functions, and remember that you can always compare these.